All right, guys and girls, we're going to start first video of section 9.3. We're going to go through a process you've most likely never seen before. Generally, we're going to try to find trigonometric functions of any angle. And something you don't know is that you can generalize right triangle definitions of trig functions so that they apply to any angle in standard position. Angles in standard position meaning where we have a side along the origin, our standard side, and our terminal side here. Now, sigma is right there, but we're going to end up using the triangle you see formed by this circle and this terminal side. Now, there's a couple good things we get to do here. So first of all, if that's x, then that means we went -4 back on this triangle from the origin. We also went 3 up from the origin. So that gets a little messy in there. I don't like the way that looks. But we go 3 up. From there, I know we have an r there for radius because we don't know the radius of the circle, but we can find it out using our friend the Pythagorean theorem. So if we go 3 squared plus -4 squared equals r squared, and then we solve it out, 9 and 16 is 25. And then we can say something like r equals 5. Well, now we know that our hypotenuse is 5. So after using the Pythagorean theorem, the next thing I'm going to show, well, I'm going to write out all 6 trigonometric functions: sine, cosine, and tangent. Cosecant always screws me up. Secant and cotangent. All of these other 3 just being the flip of the original 3. We're also going to reference SOHCAHTOA to get through this. So what we're looking at then is sine of theta. We're going to be able to use this angle right here in reference to our sigma there in red. Even though they're not the shared angle, it's a reference angle. It's an idea that we're going to come across a lot. So let's just get through the mechanics of this and then worry about why it works. So opposite of this green angle is 3 over the hypotenuse is 5. Adjacent to that green angle is -4, hypotenuse of 5. Opposite of that angle is 3. Adjacent is -4. Cosecant is the flip of sine, so instead of opposite over hypotenuse, it will be hypotenuse over opposite. Instead of adjacent over hypotenuse, as in cosine, secant will be hypotenuse over adjacent. And cotangent, instead of opposite over adjacent, will be adjacent over opposite. So that's what we're looking to do right now. Don't worry so much that the angle that we just referenced here in green is not, in fact, this angle. There is a relationship between those two about why this works. So let's just see if we can crank it out for this section. So from here, we went 3 over according to our x. We went -3 down according to our y. Let's go 3 squared plus -3 squared equals r squared to try to find our missing radius. 9 plus 9 is 18 equals r squared. Square root of 18 equals r. If we simplify that, it's the square root of 9 times the square root of 2 equals r. Then we have 3 root 2 equals r. So I can put 3 root 2. So I got my whole triangle starting to work out here. And then I'll get rid of this work so I have room for my trigonometric functions. And I'll go sine, cosine, tangent. I'll go cosecant, secant, cotangent. And then purely just back to the SOHCAHTOA reference. Notice now I'm going to reference this angle. Again, we're just going to trust that, well, actually that's our exact sigma angle, so we should be good to go. But opposite over hypotenuse, couple issues there. -3 over 3 root 2. We're going to cancel 3's and have -1 over root 2. Don't like radicals on bottom, so root 2 over root 2. And we get negative root 2 over 2. And that simplifies out. So negative root 2 over 2 is an answer we're really looking for. Cosine adjacent to that angle is 3 over 3 root 2. So we're going to do a lot of this same scratching out. 3 over 3 root 2. Cancel the 3's. We got 1 over root 2. Multiply by root 2 over root 2. And get root 2 over 2. So what I'd really want here is root 2 over 2. Tangent is negative opposite of this angle, green angle, opposite -3 over adjacent, which is 3, which simplifies to -1. So now what I'm going to do is I'm going to cheat a little bit to speed this up. If this is sine and this is the unsimplified version of sine, and that is hypotenuse or opposite over hypotenuse. We know that cosecant is the flip, so it would be this, that bottom side over this. And then if we simplify, cancel, we're at negative root 2. That saves me some of this. I still want this answer for sine, but I want this answer for cosecant. So now I'm looking at this one for cosine, that's adjacent over hypotenuse. So if I flip it, and then cancel the 3's, I got root 2. And then if I flip the tangent definition of 3, or opposite over adjacent to adjacent over opposite, I still get -1. Running out of room, y'all. So I'll let you take a picture of that in your brain, hit pause, use whatever you need. Now I'm going to erase it all so I can get to these last two. All right. So our first step, if you're remembering right, let's complete out this triangle here. And notice where our reference angle is going to be. It's going to be right here. All right. 15 high, -8 back. So we go, I'm going to write clear over here, use plenty of room. -8 squared plus 15 squared equals r squared. 64 plus, 225? It's 289. If we square root that, is that, 17, which is great because now we don't have to mess with radicals. So now if we want to go sine, theta, cosine, not theta, sigma, tan of sigma, then I want to go cosecant of sigma, secant of sigma, and cotangent of sigma. And now I can just start rolling through these definitions. So again, I'm going to use this angle that's touching, this acute angle that's touching the x-axis is my quote-unquote reference angle. And I'm going to go opposite to that angle. It's -8 over hypotenuse. I'm going to go adjacent to that angle. It's 15 over hypotenuse. And I'm going to go opposite of that angle over adjacent. Cosecant's the flip of sine, so hypotenuse over opposite. Adjacent, not adjacent over opposite, hypotenuse over hypotenuse over adjacent, and then adjacent over opposite. So, even if you're not fully comprehending why this works and that kind of thing, I hope you're starting to get the mechanics down. Big focus on completing the triangle formed by this circle that's overlapping this coordinate grid, and then using the angle that is formed between the x-axis and the triangle. We kind of call it a reference angle. I don't know if we do call it a reference angle, but that's what we're using every time. So let's see if we can do it one last time. So if I complete this triangle that ends up being formed by sigma there, right? It goes negative 12 down because of the y. It goes negative 5 back because of the x. Our reference angle, I hope that you can see, is there in green. Let's do some Pythagorean theorem real quick. Negative 5 squared plus negative 12 squared equals r squared. 25 and 144, like 169. If I just use my Pythagorean triples, I'd know it's a 13 already. So our hypotenuse is 13. Again, we will do 6 trigonometric functions. 6 trigonometric functions. And now we're going to use our reference angle, which again I'm going to highlight. We're using this reference angle. So opposite is negative 5 over hypotenuse 13. Adjacent to that reference angle is negative 12 over hypotenuse of 13. Opposite is negative 5 over adjacent is negative 12. Now we're going to go hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite, adjacent over opposite. So I should be able to cancel negatives there and leave it as 12/5. I should have also canceled negatives here and left it as 5/12. Notice how the references here, or the final answers, are just reciprocals of each other. All right, so that's target number 1. Can you evaluate 6 trigonometric functions given this setup? Coordinate plane, circle, a point on a circle from the angle. We'll get more into the hows and whys of this. Right now, I just want you to know what to do. All right, so I hope that through these 4 examples, you can kind of repeat this process and maybe tear into some book problems that match it before we get on to unit circle thoughts. I'll see you again in part 2.